CNN development, CNN model development, convolutional neural network model development using deep learning techniques, where the end product is going to be a system that is that can train images, and then okay, now so this Jupyter notebook feature extraction.ipymb is the one I'm going to use for training the actual model. So first of all, I import TensorFlow, a predominant package developed by Google for deep learning CNN development using deep learning techniques. Then Keras, of course, I need ResNet 50 for transfer learning in order to make things easier. So I have downloaded the model, and then Global Max Pooling 2D for a feature extraction. So I will load the ResNet weights, and then for feature extraction using sequential means, and then import OpenCV for images identification, and then object detection. OpenCV2 is an OpenCV library, which is more of image detection library than NumPy, in order to actually resize the images to 224. This one is for testing. So it is going to read, for example, this image, and then it is going to convert it to 224 by 224 for proper pixels, in order to let the model use this format to teach the system for image search engine. Then convert to array, and this is the shape, RGB 224. Then expand, then pre-process image, then resulting model is going to be predicted and flattened. You normalize the result, print the shape, and then this function is for feature extraction, using convert it first to read the image part, resize the image, put it into array, expand, process, then predict the model, and then flatten, normalize, and then return normalized feature. So this is an example of how the features are extracted in numbers for computers. So models tends to work well with numbers. Then so importing TQDM to give a progress bar. you know Funny enough, I have found this in an Arabic transcription or something, saying that it means taqaddam or something, which means progress. Okay, so then load the file name, feature list, and then loop into the data set, which is located, I believe, here. So let me just reveal it in File Explorer for us to see the actual data set. So all these are the data sets, combining fashion products, and yeah. So these are uploads for training, for testing purposes. So let's go back to the code. The file name is here, these are the data sets, then TQDM is doing its thing, then it is going to extract the model and save it as feature vector and file name WB. So basically these are the models being trained. These are the models, and these are the two models here. Then main. Let's go to the main folder. So for working with this, we need Flask to render the template, and then for everything. Now we import NumPy, the pickle, which is responsible for loading the models, and then TensorFlow, NumPy, and OpenCV for image detection and recognition. Then we load the ResNet 50 weights, then extract features as usual. Then the recommendation, use the k nearest neighbor to see how distant are there. That is how distant are the numbers while the features have been extracted. So it is going to recommend those, and at least it is going to provide 6 of those. And then this is this is the function for uploading the files, passing it to the actual feature extractor, and then recommendation system. And then if there are no files, it's going to show this. If there is an error, it's going to show this also. So this is the name of this thing, of the template, cnn.html, basically just for collecting data. So this is it. There is a lot of work needed here for presentability, but the results are more important. So basically that is how the third and the most difficult part of the project works.